We have now a mechanical system, a more significant mechanical system in front of us. And so the idea here is to show you how to build a bond graph model right on the physical system so that you can see a one-to-one correspondence between the elements of the system and your bond graph model. So let's begin here by identifying the distinct velocities, which are the ones that we want for the purpose of starting the model right here. This would be a 1. There's one thing that I need to tell you, that there is a force on this, and let me just, so that be consistent with the color, I'll just put it in here like a force in here. Anyway, I starting to put the velocities first. A 1 over here, and you put a 1 over here. We could put again the reference as 1s 2, so that it makes it a little easier to draw the bond graph. But you could simplify this ones. But this would be with velocity equals to 0, and then velocity equals to 0, and we could simplify this. But what's the next step? On each one junction, see what elements experience that velocity. So we have this would be I with value m sub 1. You will have this I with value m sub 2, and you will have this I with value m sub 3. In here I would do a source of SF in here, and then with value velocity equals to 0, and then I would do it over here also, SF with velocity equals to 0. Then that's all on the ones. Now the relative velocities we could do anywhere. This is always going to be higher than this, so because we can, on this like in here we have a 0 with a 1, and this 1 is, if this is b sub 1, and this is, we usually use x1 dot, right? And this would be x2 dot, sorry, this would be x3 dot. So this would be x1 dot minus x sub 2 dot, and that difference is being seen by the C element and also the R element, which would be in this case, if this would call it case of 2, let's call this case of 1, and this would be case of 3, and then case of 4, B sub, let's do this B1, B sub 2, B sub 3, and B sub 4. So in any case, that's what this would be. The value of this C would be 1 over k sub 1. The value of this R would be B sub 2. In between these two, I think we have the same thing. Okay. And then you will have, this would be x sub 1, x sub 2 dot minus x sub 3 dot, like that. We have the C and the R the same way. Yeah, with value 1 over k sub 3, and they are b sub 3. in between these two we will have this again, one with the C and the R element with value 1 over k sub 4, and this with value b sub 4. Yeah, pretty soon we are getting there. We're almost done. I think we only need this one, and this would be a 1 with value x sub 1 dot minus the velocity, and this we know is 0, and then we have to put the C and the R element. See, this is pretty significant now, 1 over k sub 1 and b sub 1. Okay, and with this we have done this bond graph model of a mechanical system.
Wait, I think you're missing an R.
Yeah.
We are missing an R element someplace.
Yeah, K5.
Let's see. This over here. Oh,
The damper line.
yeah. Here's a little problem. Now that you pointed out, we need to do this right, because this is between. No, this is not correct. Right here. This in here. You see, this is correct to the point that we have the. Thank you for pointing it out. This is this the C, which is 1 over k sub 3. But this in between, these are connected one after the other. So this is like we have another one junction in here to make life a little easier. In fact, I am going to do that. And then between these two, you see, we can connect this C element, and between this one and this one we will connect this R element. Although I could have put it off of a 0, I don't think that is as clear as now. So you have it in here, and if we want to, we could practice the causal assignment. That's the last thing we're going to do here. So this would be.
Do we have to include that force as a source of effort?
Yes. Also, in here we are missing something. There's force in here. Would force us to put 1 in here, right? SE, and now I think we have it complete. So let's just do the causal assignment. Like I said, that's the last thing we're going to do. In here we put the integral form for the I, makes this ones like this, yeah, and then this flow is going to be like this, makes this like this, and that makes this two like this. So we are over here, go to the other I, and that makes it like this. When you have two of this, the 0 has to have 1, and that makes this two like this. And in here we have this one. This one makes this two like this. And in here we have like this, the other one, and then the floor, and I think we have it. Okay, that is complete.